Hi guys, we're back with the quotient property of square roots. Now remember, we just did the product property, and that's when we were multiplying under a radical. The quotient property is when we're dividing under a radical. And they're very similar because when we do these things, it basically means I can separate the quotient or the product into two different radicals. So the quotient property of square roots, if we look over here under symbols, I have the positive square root of a divided by b. So I could write that as the positive square root of a divided by the positive square root of b. So if I use that property here with the positive square root of 5/9, I could change that to the positive square root of 5 over the positive square root of 9. And we know that the square root of 9 is 3. So my final answer would be the square root of 5 over 3, which is more simplified than having a radical over the 9 because the 9 is a perfect square. Okay, now they don't always look that beautiful when we use this property. So in this little note here, it says, when applying the quotient property of square roots, we cannot have irrational numbers left in the denominator with a fraction. This means we cannot leave any imperfect roots in the bottom of the fraction. When this happens, we need to do something called rationalizing the denominator. So let me just review if you're not quite remembering what an irrational number is. An irrational number is any number that cannot be represented with a fraction or a decimal. And one of our most popular types of irrational numbers is an imperfect root. For instance, the square root of 2. If you would type that in your calculator, you would get an ugly decimal that never ends, okay? So you could not write that as a decimal. You also could not write the square root of 3 or the square root of 8. Get what I'm saying? All right, so any imperfect root in the bottom we need to get rid of. In order to do that, we do the process called rationalizing the denominator, which is just using multiplication to eliminate that radical in the denominator. So I have 3 examples here. Rationalize the denominator in the fractions. All right, letter A. I have 2 over the square root of 3. All right, so here's how we do it. To get rid of a radical, you multiply it by itself, and I'll show you why this works in a second. So if I have the square root of 3, I'm going to take it times the square root of 3. Now, if I'm going to do that on the bottom, I also have to do that on the top because rad 3 over rad 3 is just 1. So I really just multiply them by 1. I'm just making it look different. So in the numerator, that's 2 times the square root of 3. And the denominator, I have the square root of 3 times the square root of 3, which is the square root of 9. Since they're both under the radical, you can multiply them. Now the square root of 9 is 3. So I end up with 2 rad 3 over 3. So do you see what happened here? My rad 3 times rad 3 just turned into 3. So I rationalized it. If I look at B, I have 2 rad 5 over rad 7. So what I need to eliminate is the rad 7. So I multiply by rad 7 over rad 7. In the numerator, the 2 has to stay outside of the radical, but because both the 5 and 7 are under, I can multiply 5 times 7 and I get 35 under the radical. In the denominator, 7 times 7 is 49. Now, 35, you ask yourself, does it have any perfect square factors? And it actually does not. So this is like completely reduced in the numerator. But in the denominator, we know that the square root of 49 is 7. So that would be a rationalized denominator. Finally, letter C. The only thing that's wrong with this one is the rad 2 in the denominator. So I only need to multiply by rad 2. You do not have to multiply by the 3. That's an integer. That's a good number to have in the bottom. So in my numerator, I have rad 3 times rad 2, which gives me rad 6. In my denominator, I have 3 times rad 2 times rad 2, which would be rad 4. All right, so that's rad 6 over 3 times the square root of 4 is 2. So that's rad 6 over 6. Now, as badly as you want to cancel those 6's out, you cannot, because that numerator is not 6. It is the square root of 6, which is a much different number than 6, which is in the denominator. All right, so the reason we did that is because we're going to use our property, our quotient rule, and see if we end up with anything that's irrational in the denominator, we're going to have to use that process to make sure that it is a rational number. All right, letter A, the square root of 25 over 49. First thing you want to do is see if you can reduce that fraction, 25 over 49. Unfortunately, you can't. There are no common factors. So you split up the radicals. So rad 25 over rad 49. Now this is a very beautiful one because the square root of 25 is 5 and the square root of 49 is 7. So this is just a fraction, 5/7. No radicals left over because those are both perfect squares. Moving on to B. I have the square root of 64 over 5. 5 does not go into 64, so I'm going to move on to separating my square roots. So I have the square root of 64 divided by the square root of 5. Well, the square root of 64 is 8, but the square root of 5 is just that, the square root of 5. So I need to rationalize here. I need to multiply by the square root of 5 over the square root of 5. So in my numerator, I get 8 rad 5 over 5. Because I hope you've gathered that when we multiply the radical by itself, you just end up with what's under the radical, because this would be rad 25, which is 5. All right, 2 more. Letter C. The square root of 27 over 24. First thing I asked myself, do they have any common factors so I could reduce this fraction and not have to worry about such large numbers? And in fact, both of these are divisible by 3. 27 divided by 3 is 9. 24 divided by 3 is 8. And now I don't have to deal with such large numbers when I'm making 2 radicals. In fact, now I just have 3 over the square root of 8. Well, the square root of 8 is not okay. I need to multiply by rad 8 over rad 8. So that's 3 rad 8 over 8. But then I hope you guys notice that rad 8 can actually be simplified using the product property. The square root of 8 is the same thing as the square root of 4 times the square root of 2. And the square root of 4 is 2. And I can take 3 times 2, and that gives me 6. So I have 6 rad 2 over 8. And finally, I actually can reduce 6 and 8, right? They're both even numbers. And so I can change that to 3 rad 2 over 4. Lots of steps in that one. And there's different ways you could have gone about that. Like I could have simplified this radical right here in the beginning. But every step we did there was legal, and it worked out. All right, the last one, D, the square root of 32 over 25. 32 and 25 do not have any common factors, so I'm just going to go ahead and split up the radicals. The square root of 32 over the square root of 25. I know the square root of 25 is 5. That's beautiful. That means I don't have to rationalize the denominator. Square root of 32, I could do 4 times 8, but I could also do 16 times 2. And I'm going to go for 16 times 2 because 16 is a perfect square. So that's going to be 4 rad 2 over 5. All right, guys, that is simplifying radicals, and we will finish with solving tomorrow.